welcome to the solution for Leetcode 2654, the minimum number of operations to make all array elements equal to 1. So in this example, we have 2, 6, 3, 4, and when we choose these two elements, the GCD is 1. So we can use this 2, 6, 1, 4. Then we can choose index I equals to 1 and replace nums 1 with GCD 6, 1, and we'll get the value 1. And it will become 2, 1, 1, 4. And we can choose the index 0, and then it become 2, 1 becomes 1, 1 because the GCD is 1 again. And then we can choose the I of 2, and then we can replace nums again with GCD 1, 4, which is 1 again, and is 1, 1, 1, 1. In this case, it's impossible to make all elements equal to 1 with the GCD, so therefore we return -1. So now let's go to the board. Now, in this example, the answer would just be 2, because what will happen is that it will become 3, 1, the GCD of 3 and 1 is 1, and then after that the GCD of 1 and 1, 5 is going to be 1, 1, 1. So what we can see from here is that whenever there's a 1 value, or there are 1 values, you can just take the length of the nums array minus the number of 1s present. So at the start, what we'll do is we'll count the 1s. If 1 is greater than 0, then we'll return length of nums minus 1. However, a lot of times there won't be any 1s. So this is what we're going to do. We're going to set the difference to infinity. Then we're going to loop through the nums array. We're going to set a variable g equals to nums. Then we're going to loop through nums from the I plus 1 position. So basically, if you start from 2, we're going to loop through nums from 6. And then we're going to use g, which is the GCD of nums I and nums j. So we're going to basically reset the g variable from nums to the greatest common divisor of nums I and nums j. So in this case, once we are at 3 and we loop from 3 to 3, 4, we're going to find that basically g equals to GCD of nums 3 and 4. And in this case, g is going to become 1. So if g equals to 1, what we're going to be able to do is we're going to change the difference variable, which is initially infinity, to the minimum of difference, so it's infinity, and j minus I, which is 1, because j in this case would be 0, 1, 2, 3, and I in this case would be 2, so 3 minus 2 is 1. So g would then be, then the diff will then become 1. So at the end, we're going to return -1 if diff equals to infinity, which will be the case in this example here, 2, 10, 6, 14. However, if it's not equal to infinity, then we're going to be able to return diff, which in this case is 1, plus the length of nums, which in this case is 4, minus 1, which is 3. So that will be 4, which is the correct answer. Now, in this case of 6, 10, and 15, initially what's going to happen is when we're going to reach 10, and we're going to loop from 10 to 15, so g equals to nums I, which is 10, nums j is 15, loop through nums from I plus 1 position, so it's 15. So g equals to GCD 10 and 15. Wait, hang on. Sorry. I'm wrong. GCD 10 and 15, I believe, will give 5. So I'm wrong. Wait, hold on. What I mean to say is we're going to loop through from GCD 6 to 10. And in this case, the GCD of 6 and 10 will give 2. So g equals to 6 initially, and nums j equals to 10. And so g equals to GCD 6 and 10, which will give 2. Now, nothing happens because g equals to 1. So what we're going to do is we're going to loop through again. So now we're going to be at 15, right? Because previously we're at 10, now we're at 15. And remember, g is no longer 6, it's 2 because of this operation here. So now g equals to GCD of nums. Sorry, this is wrong. Aha, you got me. So GCD is GCD of g, and basically nums j. So again, remember, g has become 2 at this point. Although in the execution stack of the program, this variable of nums remains completely unchanged. But in this case, g is equals to the GCD of g, which is no longer 6 but 2 because of the previous operation when we did GCD of 6 and 10. So g is now 2. So g equals to GCD of 2 and nums j, which is 15. So the GCD of 2 and 15 is 1. So now g becomes 1. So if g equals to 1, diff equals to min of diff j minus I. So in this case, j is 2 and I is 1. So 2 minus I is 2. Alright, so return -1 if diff equals to infinity. No, because diff is 2. Else diff is 2 plus length nums minus 1. So in this case, length of nums is 3, minus 1 is 2, so 2 plus diff 2, which is 4, which is correct. So I think the key to understanding why this works is, in this case, even though in the execution stack of the program, we don't actually modify the array or the list, what will actually happen if we're able to do it is we're going to do GCD of 6 and 10, we get 2, we're going to replace 10 with 2, and then we do GCD of 2 and 15, we're going to get 1, and we replace either 2 or 15 with 1. In this case, we replace 15 with 1 here, so we're at 2 changes, and then we're going to make one change of GCD 2 and 1, and we're going to get 1, and we're going to do GCD of 6 and 1, and we're going to get 1. So that's basically the whole idea behind this algorithm. So you can try coding it out, but I'll also try to do it as well. So we're going to do once equals to nums.count 1. If once, we're going to return length of nums minus once. Now if not, what we're going to do is we're going to set diff equals to infinity for I in nums. Sorry, I think we're going to do range nums is better. G equals to nums I for j in range, and we're going to go from I plus 1 value nums. G equals to GCD G nums j. If G equals to 1, diff equals to min diff j minus I. And at the end, we're going to return -1 if diff equals to infinity, else diff plus length of nums minus 1. Basically, diff represents the number of transformations needed to get the first one available, assuming there were no ones previously. So let's try it. My bad. Okay, we're going to use some example test cases. Oh goodness. And we're going to try 15. And it's still correct, so let's try submitting it. It's accepted. Alright, I hope you enjoyed the explanation. Thank you so much. Have a good day. Bye guys.